I've ever carried. I put a record when I was doing one in Microsoft Office, which it was interesting.
Oh, and then we did one in Perth, right? We did a few in Perth.
Yeah, we did a few in Perth. It would be around the same time 2 years ago, right? In a couple of weeks, we were. When was it? Was it in November, December? We were in Perth?
I think it's November. Yep.
Yeah.
Probably good in Amazon because you only ever have to carry a maximum of 2 pizzas for your team.
Yep, that's true. And there's always not enough to eat.
Oh, no.
Keep you slim.
Okay, Mahdi, I'm going to add the link on the Data Engineers Slack channel for. Oh gosh, could you hear me on the YouTube channel? No, it's not picking up sound from the computer. Cool. Thanks.
So there isn't a Slack channel for this. Yep. So I think Slack is the best tool to make sure that you miss communication. I love it.
Are you on the Slack group?
Yes, I am. But you know, I have like 16 workspaces, and this thread concept in Slack, it just, you know, you don't get a notification when someone replies in a thread, but also it shows in on red, but it's just very confusing. I keep missing messages on Slack.
Yeah, it's not the greatest communication tool.
It's literally not solving what it was supposed to solve, to make it easy to find and communicate.
Yeah.
And for us, we still have an issue accepting outsiders' invite to work group.
Well, you're AWS, right?
Come on, but we need to collaborate.
The world is revolving around you. We are just noise outside, and then it's all noise. How's that for being humble? When are we live on YouTube? So it start behaving already?
It's already, yeah, we're already live. So we should probably stop trash talking Slack and stuff like that.
That's what I wanted to check.
I should get that back. What was I supposed to do? Yeah, I will do a chat with you, Mahdi, and send you the link. Have you got the link to?
Oh, I already got the link and send it to our internal Slack channel, that if someone doesn't have anything else to do,
they can what is it? Heckle you on YouTube, can they?
Sure, why not? They can try.
Yeah, nice.
So the order is Mary goes first, then it's me, then it's George, right?
Yep.
That's it.
20 plus 10. Okay.
Very good. We'll start at about 1:15, I reckon, just to let a few people file in. We've got about 16 people on YouTube already, so that's cool. Shane's in there. Becca O'Brien's asking, how do we heckle? Just go for it. I think Mahdi's offered himself up as a chief heckling target.
Sure.
Yeah, it is getting a bit more casual, Daniel Bartley, on the meetups, but you know, it's always been a friendly crew, to be fair. I think definitely not casual on the presentations today, though, Daniel. It's we're actually got some really cool presentations. I think I was going through Mary's presentation this morning with her, and there's some pretty cool features that I wasn't aware of with Redshift, and I think she's got a really cool demo. I think you know, Mahdi taking us through Delta Lake is going to be good fun, and of course George has got a pretty cool use case at Seek with how it all stitches together. So I think that's definitely something to watch out for. And all of our presenters today are based in Melbourne. Am I right?
That's good.
Yep.
So congrats for surviving the lockdown and your newfound freedoms, and yeah, being close to COVID free. That's a lot of respect coming from Sydney. I think it must have been a tough time, right?
Yep, you bet.
Yeah. Except for the foxes, we've been seeing a lot of those guys just roaming around everywhere. They've had the place to themselves.
Yeah. I think in Sydney a couple of weeks ago, we had a couple of deers roaming around the inner west. that was a bit odd.
Yeah, the animals are pretty happy, I think.
Yeah. And given that we've got a bit of swag, we should try to do some like swag giveaways for like the best questions at some point. I think that would be a really cool idea. What do you think? We need to talk to the Databricks and AWS marketing teams to sort of yeah, ramp up the swag effort. Actually,
Do you already have some from Databricks, or do you want me to have a chat with Joe?
yeah, no, I got a package. I think it's, but I don't actually have shirts. So yeah, I need to get a couple of Databricks shirts.
I'll ping Joe now. See what.
So from a, am I on mute?
No, you're live.
So from an AWS perspective, I'm actually also the ambassador for Women in Tech. So
Yep.
we actually have a She Build event tomorrow. So for any ladies that have attended this session and wanted to attend a She Build, I can actually get $50 credit for them to start doing a lot of stuff, and more than happy to work with them.
Yeah, there's some really good talks at She Builds tomorrow. I know Sunita from Nearmap is going to be presenting, so that's going to be a really cool talk. I think there's going to be sort of a couple of data and machine learning talks on tomorrow, so definitely sign up and tune in. I think it's going to be going live at about 10 a.m. So it's going to be a really great day of you know, talks celebrating diversity in tech, women in tech, you know, which is really good, because also data engineering is a field where, you know, it'd be great if we could get a lot more diversity into the field. So yeah, I'll be definitely taking a look at that. I think that's a really good lineup, actually. All right, well, speaking of that, we better get underway. So we've got, welcome to the Data Engineering Meetup. So it's a combined one today, as per usual during the COVID times. We're sort of doing a meetup combining the groups from Brisbane, Sydney and Melbourne. Okay. So there's a couple of AWS events. There's also, I believe, a couple of other events coming up as well. We'll make mention of them in the Slack channel and things like that. But AWS Community Day, I'm going to be running a data day on the 9th of November. That's going to be really cool. The URL to sign up is aws-community-special-edition.splash.com. I should have really just made that a bit more clearer, but you can sign up. I'll make sure that everyone knows about it. And that's going to be a really fun day of sharing of best practices from the community. So that should be good fun. But I digress. We have an awesome meetup on right now. We've got Mary Law. She's a specialist in the data analytics space at AWS. Mahdi Askari, he's presented here before at the data engineering meetup. He's a solutions architect at Databricks. He'll be talking to us a bit about Delta Lake. And then we've got George and Pongracz. Is that the way?
Yeah, Pongracz.
Pongracz. Okay, cool. So he's a data platform engineer at Seek. He produced a really interesting Medium article recently of how he's kind of combined Redshift Spectrum and Delta Lake, which I think everyone's going to find super fascinating. So it'd be interesting to find out from folks who's using Delta Lake and Redshift, whether it's combined or on their own in production today, before we dive straight into the talks. But our first speaker, of course, is Mary Law. We're going to be taking questions on the Data Engineers Meetup Slack group and also on our YouTube live stream. So feel free to pop in any questions that you have for any of our speakers. But yeah, aside from the fact that Mary Law is a principal specialist in big data and analytics at AWS, she actually loves spending time mastering her patisserie skills. So perhaps after the talk, you can tell us some of your awesome creations. So I'll stop sharing and I'll let you take it away, Mary.
Thank you. Thanks, Peter. Okay. Okay, let me just share my screen. Okay, you guys can see my screen? Good, cool, thank you. My name is Mary. I'm actually a principal specialist at AWS. My focus is actually on data analytics, but I actually have a special focus on operational side of things. So anything to do with operational excellence, scalability, security, new features that can actually help you to drive the operational excellence, this is what I'm here for. So in today's talk, I'll be talking about the Redshift Spectrum, more about Spectrum, how it can actually help to power your data lakehouse architecture. So a quick introduction of what is a lakehouse architecture, the Redshift and Spectrum overview, materialized view, lake formation, and some demos. So in this talk, we'll cover some of the areas that Seek has been using Spectrum and materialized view. Now, we heard from a lot of companies that they're looking to extract more value from the data. So more data, new sources, increase of diversity of data, but how can we actually make sure that we make use of the data nicely, securely? And this is what we are going to do today. Have a look. Okay, so in terms of the Lakehouse architecture, we are actually seeing more and more customer taking advantage of what we call a data lake. So with Redshift, we actually have like the data warehouse that we have, as well as a data lake that's usually sit in an S3, as well as now you can actually even combine the data from your transactional database, which is like your Progress SQL. So Redshift is special because it's not only the solution that will give you 1 foot in the data warehouse, but it's also 1 foot in the data lake. So that's why we actually call it a lakehouse. Now, this gives you the flexibility of storing your highly structured data in your Redshift, keeping that exabyte of structured, unstructured database in S3, and then seamlessly combine them both to give you the insight. So Redshift is the only data warehouse that you can actually use to extend your query across to your S3 data lake without moving in or even transforming any of those data. And we will see in the demo later on. Now, with Redshift Spectrum, you can actually query any open file format that you already use, like your AVO, CSV, JSON, ORC, and Parquet. And in September, we actually announced the support of native Delta Lake format and the Apache Hudi, which is copy on read file format as well. So let's have a look. So as well as the data lake, you can actually use something called what we call the lake formation. So you can actually create your lake very fast, scan the data in your S3, create the database, create the tables, and you can even have security access control. So this talk is actually going to focus on Spectrum. So I'm just going to quickly go over what Redshift in. So Redshift actually have some leader node that contain store the metadata, organize the SQL between the JDBC and SQL processing. But more importantly, I just want to highlight here the importance of what we call the Redshift Spectrum. So Redshift Spectrum, it's actually a feature of Redshift. So behind the scene, we have different set of node type that you can actually allow to query data in your S3. So each of the slides within your Redshift cluster by default will have 10 Spectrum node. So for example, if your cluster is actually having a 10 node of DC2, you potentially have 20 node of Spectrum on top of what you have currently on top of your Redshift compute. Now let's this RA3 is a new instance type. So with the moving to the RA3, we don't even need to use what we call a Spectrum, because Redshift behind the scene will manage the Redshift storage, which is sitting on S3 and move the data in and out. But this is just more for the completeness. So when we talk about Redshift Spectrum, what is it that it is so special, right? I mean, it's not an AWS service. It's just a feature of Redshift that allows you to query your data that's residing on S3, like the S3 data lake. And one important point to note is that with a Spectrum, you can still leverage your S3 storage class. So for example, I have data which is in my standard bucket. Over time, I may want to move it into an infrequent access bucket. And Spectrum can also actually support your query against those infrequent access bucket as well. So that gives you the flexibility to archive the data at a cheaper cost. So with the S3 data lake, it actually has the potential to store exabyte of data, right? And you can just store everything in there. But it's also important to know this external data, what we call the external data, is actually query in place. So you don't actually need it to move into your Redshift. And like I said before, it is supported by a whole heap of maintained fleet of node. Now, with Redshift, what we normally recommend if you've been using a S3 as your data lake, it will be a good idea to leverage Glue or even Apache Hive as a meta store. So whether you actually have enough data to justify a warehouse or you're just getting started, having a data catalog will give you that feasibility as in having some kind of control within a big data lake. I mean, a data lake not having control, it's eventually it will just become a data swarm. Everything will just go all over the place. So with Redshift, it actually keeps your data where it makes sense. So when you actually use Redshift, you can query the data directly on Redshift, keeping the data hot and warm. With the data that is not so warm, you can actually potentially move it off to S3, or what we call the unload to S3 data lake. And we will actually have a demo showing how you can actually move some of the data from Redshift into the S3 data lake in a structured manner way. So Redshift Spectrum also allows you to make the analysis using what we call glue or the EMR. So let's just say if you have an open data format that's sitting in S3, you can actually share those data files with a user that's using glue or even Athena. So one nice thing about Redshift Spectrum is that it's always available to you. And if you actually, you can choose to use it now. If not, you can always use it later. So in September this year, we actually announced the new Delta and Hoodie features being supported by Redshift Spectrum. But in these slides, you can actually see there's actually quite a lot of new features being added to Spectrum. Now, Spectrums actually support complex joins, nested query, Windows function, and external table, as well as what I'm going to cover soon, which is like materialized view. So the external data can be partitioned in a number of ways. And out of the box, if you actually unload your data from a Redshift table to what we call the S3 bucket, you can actually even partition by using some order by, or just use the word partition by. So Redshift will actually run those unload in parallel because of the massive parallel processing features. So with that, Redshift Spectrum can also use a data catalog to transverse the external data. And for that, we actually use glue catalog, or the EMR Hive metadata can be used. So you can actually query your data against your S3, no loading required, and then you can actually pay as you go. So the way it works is we actually charge you by per terabyte, $5 per terabyte, but it's in per rata of 10 megabyte. So if you can actually compress the data, make sure that you have a good partitioning strategy, making sure that the predicate columns actually get pushed down, you can potentially save a lot of money as well. So as a side tip, reduce the terabyte scan by compressing data, partitioning data, and using a columnar file format such as Paquet. So, and the demo will actually show you how it can be achieved. Now, Redshift has new features called materialized view, which some of you may know, or some of you may not know. So this will actually provide you that transformational speed for the typical workloads such as dashboard, or any of those that you actually need the result of using combined joins, aggregation, or even across multiple tables. So it's really important here to highlight, you can actually use materialized view to combine several tables into what we call a summary tables, and then serve it to your BI users. Now, materialized view allows a user to materialize the content of a views, but behind the scene, it's actually a physical table within Redshift. So compared to the normal view, we don't actually have to build the table from scratch. So it actually supports predicates, joins, and aggregates, right? So a full refresh can be depending on the query type, but most of the time, most of the query that user actually been using, we actually support the incremental refresh as well. There will be some new features along the way that we will be able to automatically rewrite the query if we know the query will be using those typical MV by looking into the machine learning behind the scene. So that will be an upcoming feature that will actually make this materialized view very powerful, because we can always predict well in advance whether that particular query in the past have used MV, and we will actually go and do that as well. So now with the query rewrite, it's very useful, especially when the data engineers or the DBA create all this necessary materialized view, but they don't even need to modify the user workload, right? I mean, the dashboard will be able to reference the materialized view, and then Redshift will automatically leverage the materialized view whenever possible. So this is only for a materialized view for rewrite only when materialized view have the latest up-to-date data. So in terms of the feature benefit, we have been working with a lot of customers, and a lot of the customer has provided the feedback that using materialized view, it actually gives them at least twice to 10 times faster performance on some of the most complex query, especially the one that is actually normally used in dashboard or analytic workload, because it's predictable. So you can actually create a summary table and just point those dashboard to use as summary tables. Now, the key capability as part of this update is we actually allows you to have a user control creation, management, and refresh of materialized view. So management and materialized view is actually very seamless in Redshift. So how does this work? I mean, how does materialized view work in Redshift, right? I mean, Redshift Query Optimizers is actually enhanced to make use of the MV to efficiently process any query behind the scene. And behind the scene, we actually have what we call the MV manager as well. So this materialized view manager behind the scene will actually continuously monitor the query workload. And then we actually apply a machine learning algorithm to automatically create and maintain the materialized view to boost the query performance. This automation is actually integrated with our workload management. If for those of you that have been working with Redshift, capability to schedule and control the timing of your materialized view refresh. So with the built-in materialized view functionality, customer, you don't even need to worry about those expensive and tedious workaround by joining multiple table to do similar thing. I mean, the query will just get the best performance automatically. Now, the next innovation, when we talk about data lake, right? I mean, it's data lake and AWS integration. It's what we call Spectrum and the Lakehouse integration. So many of you may have heard of this Lakehouse lake formation before, but Redshift Spectrum now actually integrate with a Lakehouse formation catalog so that you can even actually provide the table and even up to the column level access control for fine-grained security. So how this works is, okay, so we use Redshift Spectrum to allow the Redshift query your S3 data without loading the data. And then we actually get the Spectrum to integrate to the lake formation. So it's more like a managed data lake on AWS. So this integration allows the Redshift Spectrum to deliver a table column control. So the administrator need to have an IAM role for the Redshift using a lake formation enable glue catalog. So once you have the glue catalog and you actually run the crawler, you can actually see your S3 partition, and then you just go into the lake formation to say, okay, for this particular database, for this particular table as Spectrum, which column would I want to share with the users, if not all? So you can actually have that level of control. So now this is, before I actually jump into the demo, this is what the demo is trying to highlight. So the first one is actually a materialized view, as you can see, based on a TPCH database. And I'm actually, the first one is actually just do a SQL select from these 6 tables, 5 tables. And you can see the first time that we actually ran it, it actually scanned about 18 gig of data, and it took 1 minute. And then we actually literally use the same SQL, but we actually create a materialized view based on this SQL. So we end up creating a materialized view called MV area summary, and then run the query selection from this particular MV table. And as you can see, the number of data scan has actually reduced significantly. Now, imagine if you actually moved the data off to S3, you can, for archival purpose, you can actually save a lot of money if you actually just pay for the $5 every terabyte scan. And then the next one is, now we have the ability to write to S3 from Redshift directly. So in the past, you may need to unload to S3, but now you can actually just write. What I can do is I can just create what we call a Spectrum schemas, just create a schema, you can call anything, and then put it in your data catalog, which is like, I've pointed this data catalog in my glue catalog, give the IAM role the ability to access the data catalog, and you can actually just create an external table. Like in this case, I actually create an external Spectrum table. Oh, sorry. I create a Spectrum table, and most important thing is, as soon as you mention the word store as Parquet, this Redshift will actually write off the data as a Parquet file, and it will actually leverage the snappy compression. And then you actually just, all that you need to do is point it to S3 location, and then you can even do a select from the table. Now, to make it more sophisticated, for example, I just want to do an order for order customer with the key less than 1,000. You can even just do like a partition by. So by ordering the partition, the next time, if you actually wanted to query the database on customer key, it will be very fast because it's already partitioned by the customer key, so we can leverage the predicate columns. Again, point it to S3 location. So, and out of the box, Redshift will use a parallel processing to write the files into multiple even size per data files. And then the Parquet file itself is actually encrypted using the standard S3 encryption, which is the S3 SSE. So coming from an operational excellence perspective, one of my best practice advice will be make sure that you use a columnar data format because, for example, Parquet is at least 2 times faster to unload when you actually use Redshift. And it's like 6 times less storage that you would save. I mean, so obviously faster and cheaper. So use columnar compression, but not the file compression. And the benefit of using a Parquet file format is it already has the min and max index. So it's kind of partially indexed as you actually store the data. Another way to actually save some costs, improve your query performance will be actually to partition the data, obviously in this case, and then try to use common filter column to take advantage of the partition. You can just create partition on most frequently filter column like by dates. We even actually support partition by date or the month. So, but just keep in mind, you don't want to have too few partition because that's not making use of your parallelism. So what we mean by parallelism is each of the Redshift node will come with a number of slices. So ideally, you want it to be in the multiple of the number of slices that you have. For example, for a DC2, which is a dense compute, you actually have like 2 DC2.large. You will have 2 slices per node. So let me just say I have 10 nodes. I have 20 slices. So you would want to ideally have like 20 slices, 20 data files so that we can actually make use of the Redshift parallelism. And then again, just be wary that you don't want to have too many partitions. Otherwise, you end up with a lot of small files. And the cost of retrieving those partition information may outweigh the partition in the first place. Now, the next thing that we did, so based on those 2 external tables, which is the Spectrum customer table and the Spectrum customer orders less than 100 key, you can actually see that we actually built another materialized view. So this is just a highlight. You can even have an external materialized view on the external table. So let's just say you wanted to use Spectrum as your data archival strategy, right? I mean, I have customers that wanted to every 3 months or every 6 months, they wanted to move some of the not so hot data into S3. But by doing so, they can still actually do joins and create a materialized view for the dashboarding just in case they need it. So that's another way of doing your external table as well. Now, writing to S3, we looked at what we call the create external table before. Now, there's actually a way you can actually move them in as a Parquet file and what we call the unload. So instead of create external table, which is read-only or workable with only Spectrum or Redshift, let's just say I have users from the data analytic teams or some other users that's using Athena, SageMakers, or any other tools, right? I mean, or even Databricks. I wanted to share with them some of my Redshift data, archival data. So what you can do, you can actually just unload from that particular table, give it a S3 location, and then make sure you specify best practice format in Parquet. Partition by, you can actually specify a particular partition and always make sure if you actually wanted to include this partition column in your data file, because out of the box, if you just specify partition by, and if you do not specify the word include, those data file by default will not include the order by in the data file itself. So allow override will actually allow you to override what's already there in the S3 bucket. So use with cautious and just specify the file manifest. And then by doing so, you can actually see like how I actually exported into S3 by the order priority from urgent to low, the number of file scans, but more importantly, it actually automatically split the file into fairly evenly sized data file. And if you look at the manifest file, it will actually give you the number of records. So for example, if you want to keep track for the next load back into S3, you can actually just make sure you check the manifest file and make sure the record is correct. Now, the last thing that I wanted to touch on is the lake formation. So we're talking about the two spectrum table that we have created externally, which is sitting in S3. So once you have your glue catalog enabled for lake formation, the next thing that you could do is go into your lake formation. Once you have set up the lake location, in this case, my data lake is actually a database sitting in a particular location within my S3. And what you can do now is I can actually go in and say, okay, for this order table, I just wanted to exclude some columns. For example, I want to exclude the order status or certain column that I wanted to assign to the users, so that you can actually restrict security access control on the table level, on the column level, and what kind of permission the user are allowed to do on the table as well. So now this is actually a quick demo, just showing you guys what we're doing. So this particular first query is actually just running through against a TPCH database, selecting from the tables from 6 of the TPCH table, which scans to about 20 gigs. And then the second one, now here, we're just trying to drop the materialized view and create what we call the summary table. So again, exactly the same query that I've used before. And then let's see how fast and the amount of data that we actually end up scanning. So now, if you guys have been using the Redshift console, you may have noticed there's something called a query loader. So you can actually click on that particular query ID. You can even go and get the execution details, the number of the total data scan. See, from 20 gig, we're down to like 6K. And you can even see the expand plan in the console itself. Okay. Now, so the next one is where we actually create an external schema. So before you actually create an external table, you need to make sure you have an external schema that's you can actually reference in a data catalog. Now, in this case, the external table will be the customer table, and I'm putting it in a particular S3 directory, and I'm actually going to partition this by the market segments. And then another external table for orders by customer with customer key less than 1,000, sorry, in a particular folders as well. And then once you have actually created those external table, you will be able to see in the console within the data objects as well. Now, if you go to the S3 bucket that you have specified, you will actually see how we actually partition by the customer segments, the market segments. And if we go into, see how by default, the market segment has been partitioned for us as well. So it's pretty handy if you want to, like, if I need to give it to the marketing analyst to analyze particular market segment, now I can only give it to the household team can actually look at the household files as well. Likewise, if you want to partition by the customer key. Now, see how the Parquet format has been set up to quite a number of equally file size as well. So out of the box, you can actually specify a max file size to restrict the file size that will get created. Because by default, the largest single file will be like 6.2 gig, and you certainly don't want a particular Parquet file to go up to 6.2 gig. So the next one is when we actually create a materialized view on those two external tables. So even external table, you can still create a materialized view. So let's just say I have customer segment file updated with 2 entry. I just run a refresh, materialized view refresh, and then I'll be able to serve this table to all my BI users. So the power of the query editor, you can actually see the execution timeline. So if at any time, if you actually wanted to fine tune some of the query, that's usually the best way to start troubleshoot and sort of understanding why certain queries actually cost higher than some of the subqueries. Now I'm just gonna skip. Okay, so with unload, this is how you actually unload the file to S3. So basically, you can actually do a select from the table. If you can actually even do a where clause in here as well. Otherwise, you can actually use the partition by, and the file will actually partition for you. And then once it's done, I think it should be. And start coming through, and you can actually see it start populating your S3 folders as well. Yeah, so it scanned about 23 gigs of data. And then you can actually see the manifest file. Now, and this is what the manifest file will look like. So the reason why we actually provide the option of having manifest file is the next time when you actually wanted to load some data file into back into your Redshift, sometimes it's actually handy to know the schemas for that particular tables within the data file. So use manifest file will be very handy. Now, this is the last bit where we can actually go into your S3 specified location within your lake formation. So in here, I've registered my S3 path to be my lake formation database. And then I run a glue catalog crawler to crawl those tables which I have created in my Spectrum, because I reference the data catalog. So for the database, now I can actually look at the tables. So which is the customer table and the customer by order external table. So once you actually click on the table, the next thing you wanted to do is, and you can actually see the location is actually S3 location. And in here, this is where you actually wanted to assign it to a particular user. For example, if I wanted to assign to the market segment teams, but I only want it to be certain formats or certain columns, excluding all the personal information, I can actually do this as well. So when the marketing team actually run a select on this external table, they will not be able to see that particular column. Okay, that's the end of my presentation.
Well, that's awesome, Mary. I think we learned a whole bunch of really good stuff about some of the newer capabilities in Redshift and the new RA3 instance, isn't it called? Yep. So that's really cool. We had a couple of questions come through on the Slack channel.
Yep.
So from Ari, in terms of performance, how would you compare Redshift Spectrum to AWS Athena, and perhaps you can talk about why you use one or the other.
Yes, so with Athena behind the scene, it's actually run on a different compute engine than Spectrum. So the normal recommendation is, if you are already a user of Redshift and if you already have some structured data in Redshift, I would recommend to use Spectrum, because in this particular way, you can actually join your data from Redshift into your Spectrum as well. Athena, it's more like you don't have anything in Redshift, you can actually just do some query. And Redshift Spectrum actually support Progress SQL as well. So keep that in mind. It will actually makes a lot of performance difference.
Yep, that makes a lot of sense. And Xiaowen, hopefully I'm pronouncing your name correctly. What tool or service is recommended to schedule a materialized view refresh?
Yep.
Lambda?
Okay. Lambda, and there's some third-party tool as well, but I'm happy to announce the auto refresh, it's not too far away.
Okay. Oh, wow. Is
Yeah.
that a reInvent preview or something like that?
Pretty much usually before reInvent, we have heaps of new features, right? Auto refresh, query rewrite, and yep.
Yeah. So Matthew Fry, he's got a bit of a curly one. So I guess the prefixes of partitions and stuff like that for between Redshift Glue and Kinesis Firehose, have they, I guess, more closely aligned those prefixes, or are they still kind of a bit misaligned?
So with the Redshift Spectrum, when you actually write to S3, you can actually it depends on how you set up in Glue as well, because in Glue you have the flexibility to set the prefix. But in Redshift, if you actually partition by or set the where clause, you can actually specify that particular prefix as well.
Yep, that's cool. All right. Yeah, so, well, that's very good. We've run a little bit over, so we better wrap it up there. But thanks so much once again, Mary. I really enjoyed that presentation, and I'm sure there was lots of questions coming through on the chat, so it was well received. We might dive straight into Mahdi's talk now. So he's going to be taking us through making data lakes performant and reliable with Delta, which is pretty cool. We've had a couple of Delta Lake presentations already, but I think this one sounds like it's going to really talk about reliability. So, once you've gotten through the installation phase, you sort of starting to look at how to make it a bit more manageable and stuff. So that's really cool. Take it away, Mahdi.
Cool. So I'm just trying to see, I can monitor the YouTube, but if you ask questions in Slack channel, I can answer it. Otherwise, you have to read the questions for YouTube for me.
No worries.
Thank you very much. Thanks, Mary. That was really good. I'm going to use a couple of things that you mentioned in your talk. So my name is Mahdi Askari. I'm a solution architect with Databricks. I thought it would be good to just give you an overview of who Databricks is and what's the offering. But specifically, we're going to look at Delta, and within Delta, there are different areas that we could have explored, but we're going to look at how schema management and schema versioning and table versioning can help you to build more reliable pipeline, and something that you probably have dealt with if you have built any kind of a data pipeline on a cloud infrastructure. So Databricks, what we offer, it's called a unified data analytics platform, typically targeted through our 3 different personas. If you're a data engineer, data scientist, or an analyst, you would be a type of people that we'll talk with. It's unified because regardless of your persona, you can actually leverage the environment and build your use cases and leverage it to extract business value. As a company, we have over 5,000 customers and we have 450 partners, and these slides are usually outdated, so going to be more than that. I think historically we were kind of like everyone relate Databricks to Spark, and the reason was the company was started by the creator of the Sparks. Like 6 individuals out of UC Berkeley. They started the Apache Spark project, but we kind of started moving also in different directions. So I'm going to talk about Delta Lake. That's another innovation that I think it was announced a couple of years ago. And then we have also an open source project called MLflow, which primarily is targeted to our data scientists, and how do we make life of a data scientist much easier, bring data governance, repeatability to the data science workload, which is usually, it's like a one-man job with you and your laptop. That's kind of bringing the data science workload to the enterprise level. And recently we acquired a company called Redash, redash.io. You can check it out. It's a visualization tool. It's open source. But now we have integrated Redash into our stack, so you can actually start building dashboards and chart, and basically you get a good visualization out of the box. So again, I promise this is the last like salesy looking slide. As a company, we are basically looking around and trying to see what are the things that the big companies like Uber and Netflix and Facebooks and Googles of the world that they're doing, that they can actually leverage their data and they can basically drive business value and be very productive with their data. And we have split those challenges in 4 high-level buckets. One is around how your data is messy and it's slow and it's siloed. You have multiple systems, different frequency of data generation, different quality, different master data, different reference data, all of those things. It just makes it hard to get your hands on the quality data. And you can see 2, 3, 4. I'm not going to go into details. So I think you can read this yourself. But there are other challenges that we also help organization to fix. So if you're looking at this and you're thinking, okay, my data actually is not messy, there are other parts of the stack that helps you with all the other 3 that you can see on the screen. But let's have a look and see how we help you to basically use your data more effectively. If you're coming from a Hadoop background or basically building any kind of a data stack, data pipeline on a cloud storage, you have some scars. You know how to dealing with an object store is not same as dealing with like a file system. You know that it doesn't give you the reliability that you want. It doesn't give you the performance you want. There was back then in 2008-9, there was a concept called the schema and read, which basically translated, write all of your data, don't care about the schema and data types when you're writing it. And then when you want to consume your data, start basically putting in a schema and data type around your data. But that essentially created a situation that you end up writing your data set for a month and month or even years, expecting a specific column to be a date time, but you ended up getting an integer, which was an error in a production pipeline, or any other issues that you ended up saving a data that it wasn't up to the standard you wanted. And consecutively, you couldn't actually leverage that to basically build the business insight, the business value that you wanted out of this. There are other challenges also. I think I have a list of challenges that building a lake house or a lake architecture, it's basically present you with these challenges that you have to solve it. And some of it, like historically, as a data engineer, for instance, you had to deal with lack of update and deletes on an object store because they are designed to be write once, read many times. And if you had to update one single row, you had to figure out how do I mimic an update operation on a file system that doesn't support updates. I think Mary mentions something around partitioning. So if you do too few, you don't leverage all the parallelism, but if you do too many, you're going to have a bottleneck on your metadata operation. From performance point of view, like you have to list all these files and say, how many files do I have? And then also you will have to pay also the cost on all of these object store operations. And then also, you will learn very quickly that even though they're very cheap and easy to use, the object stores like S3 or ADLS, they are not at the same performance level that you would have like in a spinning disk. And these days, the hardware speed is going way faster than what the software progress. So you have super fast disks that you can use as on an on-prem or on a VM. But as soon as you put your data on type of a cloud storage, you realize you're going to basically be missing on a performance bit because the cloud storages are not built for quick and responses. They're built for throughput and they're basically built for being cost optimized. So Delta help you to solve lots of those issues, right? And I think you basically, the call is recorded. You can go through every item later on and have a look and see if you're facing some of these issues. Delta definitely help you. I'll try to have a very high level overview of this slide, but we are basically talking about the schema on this talk. The first thing that you need to worry about is when you're building a lake, data lake, you need to have some level of transaction capability, because data pipelines break, and you would never think that you would put a pipeline in production and this pipeline works like a clock and it will never break, and you don't have to worry about failures. And again, going back to the behavior of object store, you will see you can actually understand like what has been written, what's not been written. So you ended up coding around this gap of capability in object store. If you have half of your pipeline run failed, you need to figure out how much of that data was written, how do you roll back, how do you make sure that you don't have half written data going to your production data and production pipeline. So that was hard. Again, the nature of object stores made it super difficult to get real-time access. We had this architecture called Lambda architecture. I think it was born a couple of years ago, which you had to design 2 different tiers. You have a batch tier, which you would have all the big data going in there. And then you have that a speed tier that your like T-1, like your current day data would have gone to that tier, use different tech underneath so you could actually query your data on a real-time basis. And that means maintaining 2 different code base, extra set of tech, extra consolidation, extra checking, all of those things. So that was very difficult. Delta solved most of these problems just by having an ACID transaction. You will see in my demo that you can version a table, you can revert to a specific version of a table. You can completely understand whether a transaction, a piece of SQL statement, Python statement ran successfully or it failed. So you will never be in this limbo of like, what happened to my data state? It's either fully committed or it didn't. The next 2 was something around metadata. As you add more and more data, and we're talking about terabytes, and petabyte scale data set, you want to find what's the best way to partition. And even when you find what's the best way to partition, an interesting problem happens. This big data problem kind of gets shifted to your partitioning. So your partition itself now is a big data problem. So how do you scale your partition itself? And Delta is basically using Spark under the hood again, right? As you heard, Parquet is fast to read. It's very economical to store. Under the hood, we are using Parquet to manage the metadata, unlike other technologies that use some kind of a relational database, which you're going to hit that relational database bottleneck. The last 3 items also, again, this is something around solving around performance of the cloud storage. It's like too many files. That means you're going to have too many like a S3 or ADLS API calls, and you spend more time listing the files and opening and closing the files rather than actually reading the data. So Delta helps you with that. But let's jump to the last one, which I think that was the topic of this meeting. It's around data quality issues. So we basically kind of looked at the past and saw, okay, schema at write, like schema at read was good, but when we are writing a data, if we don't actually control the quality of the data, we can't ensure that we can use this data when we need to. But also the reality of any data platform is the schemas change. The data type changes, the table columns changes, and you have to kind of either have to build something from scratch to maintain all of these changes and basically code for it, or you can leverage something that you get out of the box. Delta gives you some capabilities around the schema management, which I'm going to spend like next to a slide, and then I'll show you a demo on how this looks like in action. The first thing that I want to basically mention is about evolution of a schema. Basically, if you are using Delta as a target of any of your data platform data that you're storing in the lake, you can let Delta to manage some of the schema changes. For instance, we can allow users to add new columns. So when you're basically you're ingesting your data and the source data have basically added new columns, what you can do is you can turn this option on. So if you see the second, you can see the second line of this code is that turn the merge schema true. What merge schema true allows you to do is when you're doing write or doing write stream, it allows you to have new columns coming into your data without actually failing the operation. But also it allows you to basically upsize and upcast your data type. So if you had null type for a field, you can go to any other type. If you were byte, you could go to short. Short goes to integer. So that ensures that any data changes from the source that ensures there would be no data loss. it's allowed, and you can basically run the pipeline, and the pipeline runs, and the data type changes that are allowed, and it doesn't cause you to lose data. It will just go through. And also the most common scenario that you will see is you will have basically more, couple of columns get added. And when you're running this on Delta and with the merge schema true, those columns will be added to the end of your table. So if you had 20 columns and then the new data coming in with 23, the extra 3 column gets added to the end of the table. There are a couple of safeguards around the merge schema. Basically, at any operation that we think you might lose actual data, that operation will still fail. So you wouldn't be able to like go back from like an integer to a short byte, because you might have a value that basically overflows the smaller data type. So you can go to the bigger data type, not to a smaller data type, which I'm going to show it to you quickly how you can use this in action. Okay, cool. So I have a demo, and also I can actually answer some questions when I'm jumping to a demo. Let me jump to my demo. I can share this notebook after this meeting with everyone. There are a couple of other code snippets here that it goes back to, for instance, to the ACID transaction capabilities, to a streaming and batch unification. But specifically for this, I'm just going to show you the schema management. And so what I've done, basically, I've just created a dummy data set using some data that we have. If you have access to Databricks environment or even an open source, this path is something that it exists in all of the instances. You can actually run this code without an error. And just to show you, let me make this bigger. Usually this is too small. So first of all, if you want to use Delta, all you have to do is just add using Delta, all right? Similar to what you saw in Mary's presentation. If you put using Parquet, it would be Parquet. If you put using Delta, it's going to be Delta. That's basically all you have to do. From this point forward, this table is a Delta table, and it gets all the bells and whistles that comes with Delta. But let's have a quick look at the schema management. As I said, there are other sections in this notebook. I'm going to scroll down to my schema management section. Cool. So first thing first, I have created a dummy SQL statement, which I'm basically adding an extra column. If you see, I have basically ran simple mathematics, and I'm going to say I'm going to add the column called amount, and this column is double. So I'm preparing a data set that I'm going to be adding it to my table. Here, I'm saying that I have my loan, and this is a Delta table, and I want to append this data set to my existing data set. If I run this on an initial run, this is going to fail, because it's immediately telling you a schema mismatch is happening. You're writing to a table that the schema is not matched. Very easily, I can go around this, and I can just add an option here and basically say, if you get data set that's coming with different schema, as long as it's allowed to actually merge the schemas, please do merge the schemas, and it's okay. And you see now the operation was done successfully. And if I go back and query my table, which I can do that very easily here, I should have an extra column there. So you see my amount column has been added. So that's very easy to basically turn it on. All you have to do is set it. If you're thinking that you're going to have this on by default, you can also set it in like duration of your session. So as your session starts, it has this up and running. This configuration is true. But the more interesting bit is something that I want you to show is Delta, because it has an ACID transaction, it has a feature called time travel, which essentially it says we give you an ability to query every snapshot of that table, and every operation you can replay it back into the history and basically look at what the operation was run in the last 2 days and query your table at a specific point of time. That's usually when you look at all the material and the blogs and everything in Databricks that talks about data. Something that is very interesting, and it's kind of an inherent attribute of this time travel, is you can actually time travel in your schema too. So let me show you quickly what this looks like. So I've created a dummy table called Delta Foo, and this table has 2 columns. It has a column A and column B, and one is integer, column A is integer, and column B is a string. So let's run this, just a dummy table. And if I get this running, then I can do a quick select. You will see that, okay, happy days. I have a table, column A, column B, and my schema is integer and a string. Now I am basically going to say, well, I'm going to change the schema. I'm going to go and I'm going to change the column A schema to be a long instead of integer. So I run this and I'll get the same schema that I was expecting. So my table schema on a V2 is long and a string. And I can do a quick select from it and everything is okay. Everyone is happy. And now I decide to completely blow it apart. I'm going to get rid of column A. I'm going to have only column B, and it's going to be in a string. So what happens now if I select from my table, this table has only one column B, and it's a string. But here is the fun part, right? I can actually query my table and give it a specific version number. So I can say query this table as of version 0. So the version 0 of this table had 2 columns, and this table had the integer and a string column. So when you go back to that specific version, not only you get a data that was in that table as of time, your schema also time travel. I can do this as of version 1. So this will give me a table which has 2 rows in it because I add a second row, and my column A was actually a long type instead of an integer. Or I can do this, which would be the current state of the table, which you will have only 1 column. So not only you get time travel through data, but also as long as the operation you're doing is compatible and type safe, you get a time travel through a schema of a table. So you can always go back and say, my table had this many columns, and this was the data a month ago, 6 months ago, and kind of have the history come along with data and a schema. That's pretty much it for me. I'm happy to take any questions if there are any.
Awesome presentation, Mahdi, as always. Thanks so much. We do have a couple of questions. I think the offer of some swag, always gets people out of the woodwork. Simon Aubrey was bold enough to ask, can I have a Databricks t-shirt? That's what his question was. You got a response to that one?
Yes, you can have a Databricks t-shirt.
Awesome. All right. On to the serious questions now.
Probably wouldn't win the best question of the competition, but yes, you can get a t-shirt.
Yeah. When is Databricks not the right tool for an early stage startup? Is there budget and data size considerations that you should think about?
So first of all, it's not about the data size. I think it's about the use case. Like Spark might not be the answer for some of the use cases. But if you're talking about specifically, let me just bring this so I don't have to look at my other monitor. If you're talking about the data engineering pipelines and like building a data platform, there is no scenarios that say their data is too small, right? Budget obviously is always a constraint, but if you're looking at use cases, that if you are migrating any kind of a data warehouse to the cloud, if you are building any kind of a streaming application on the cloud, essentially having the principle of having storage and compute separated in a cloud in any kind of a data platform should equal to be, I work for Databricks, but you might have different reasons to go like EMR or any other solution, but I think Spark kind of is the de facto ETL framework. But having built a Spark, we understand what we need to do to kind of boost it and take it to the next level. And that's where Delta was born. So yeah, that would probably ease the answer, but happy to have more detailed conversation about the use case.
Yeah. Just real quickly on just skipping through a few questions. Matthew Fry's asked, what spatial functions does Databricks support? Is there a quick answer on that?
What the specifics are?
Spatial functions. You saw some maps on there.
Yeah. There is nothing special, as in like we don't own a spatial library that we support. If you see any Spark spatial library, you should be able to run it on Databricks, but we don't own one, we don't maintain one, so nothing special on the spatial libraries.
Yeah, Noel Hansons has asked, is there a GA date for Delta Engine?
Is it not G8 already? It should be G8 like a year and a half ago.
Delta Engine, okay, yeah.
So I know that when you're creating the cluster, we have a config that says delta.preview.on. I think we just forgot to remove that. Delta has been G8 probably from last April. Okay,
on all clouds, okay. Yep,
yes.
So yeah, good to know. On schema evolution, Pat Cobrador has asked, can you add columns in the middle? Does it support data type change?
You can't add a column in the middle. It does for a data type change. As I said, if you upcasting, you can do that. If you are also, if you want to do a data type change that is not upcasting, you are going to a smaller data type or completely incompatible data type, it's going to be completely rewriting that column for that table.
Yeah. And Anil has asked, can you refer a table of a specific version if say you are joining on a different table, or is it just used for debugging purposes?
No, it is not for debugging purposes. You can join, I can do this, join. That's a very valid join. So you can even join a table version to itself on a different version. So you can join, like you can treat this as a table, like anywhere that you have a selected statement, you can replace it with that.
Yeah, nice. One last question from Slack, from Thomas Scottwold. It's a question about Delta time travel. How do I list available versions of each table, and can you get a particular version based on timestamp rather than version?
Yes, so sorry, you can do describe history. I can't remember how to.
Right, describe. Yeah, I know, live presentations, mate. It's the pressure.
Describe history. Probably this will not work because it might be a temp table, but describe history, actually it works. So describe history will give you all the different versions, and it actually tells you how this version was created. So even if you have a streaming, you can basically pinpoint the exact batch of data that created that version, but also you can do select start from this version as of a timestamp here.
Cool. Well, hopefully that's answered, Thomas. I think we might need a few extra swag packs, but let's see whether the marketing team can come up with the goods.
Okay.
But thanks again so much, Mahdi. I think that's been a really good taking us through of Delta Lake. Yeah, thanks once again, and we'll probably see you in a couple of months or something.
Yeah, sure thing.
Cool. Well, on to the main event. If this was a series of boxing rounds or something like that, then definitely we're up for the main event of the night with George. He's going to take us through how Seek does Lakehouses in AWS. I think he's got some fascinating methods, especially getting around workload management queues and loading in data really fast. So I think this is going to be super interesting. So take it away, George.
Okay, I hope everyone can hear me. Hello, hello from Seek. I'm going to speak today about, I'm going to zoom out a little bit and talk a little bit in more detail about the entire data pipeline and also the serverless data processing platform that we built. And hopefully that should augment some of the information that was in the Medium article, but please, when we get to questions, you feel most free to ask questions about the talk or the article. So today, where we came from. We're going to talk about that, a little bit about our motivations, what we decided to do and what we built. And then we're going to do a brief demo to just run you through one of our production runs that we do against Salesforce. And then we'll just do a quick wrap up and yeah, we'll jump to questions. So who are we? We're a team of 4 data engineers and a data governance specialist. We're specialized in data from corporate and enterprise back of house systems. We follow a DataOps philosophy and approach, and we probably look after about 400 data processing jobs per person. A little history, 2 years ago, we lift and shifted an on-prem data warehouse up into Amazon Redshift. Our on-prem ETL server was replaced by a single long-running EMR cluster. And our on-prem ETL logic was also lift and shifted to PySpark SQL scripts. We decided to implement the ETL logic as a daily full load approach just to simplify the migration. So why we decided to change? Well, classic problem, I think. Completion time of our overnight batch data processing was creeping into business hours. And when we were having a failure, sometimes because of the reloads taking so many hours to run, we would miss a day. And delivery of new features was complex and slow. It was all manually deployed. So we had an opportunity when we were doing our CRM replatforming, and it allowed us to rethink how we want to do data. And we decided to focus on lead time, deployment frequency, mean time to restore and change file percentage. Now, these might be familiar to some people. There's a wonderful book on DevOps called Accelerate, and it really inspired us. And we singled our primary goal down that we wanted to accelerate thought to capability, or getting ideas of our customers into production. So what did we change? And I'm going to quickly run you through just a list of the things that changed from before and after, and then I'm going to dive into a little bit more depth about it and what that enabled us to do. But basically, deployment was manual before. Our data lake landing area was mutable. We were delivering files into the same spot every day, and it was overriding the one that was there from the day before. Orchestration was being conducted by S3 events and a Lambda function that was doing a Spark submit into the EMR cluster through the Steps API. And our compute was running on EMR, a long-running cluster. Our ELT methodology was full. It was running every day. We had a big, wide, huge cluster that could process everything and do enormous volumes, but it was running everything in full every day. And our data storage format was Parquet. And we were loading Redshift data into internal tables using the S3 copy. We had a Fargate autoloader that we were using. So now, what did we change? Deployment now is continuous integration. It's always happening. Our data lake landing area is immutable. So once a file lands somewhere, it never gets overwritten and it stays there forever. Our orchestration changed to Apache Airflow, and our compute changed to AWS Batch on EC2. And our ELT methodology changed to incremental CDC, so change data capture. And of course, we're using Delta Lake. And our Redshift data load, this was what the article was really talking about, was what we called we were no loading data via Redshift Spectrum and Delta Lake. So what did this achieve? Well, our pipeline delivery was manual. The Redshift table creation and the alteration, so the DDL that we were submitting to Redshift was manual. Our load cadence was daily and it was running overnight. Job processing was serial. So all of our jobs were going, the EMR was processing one job at a time, maxing out across the whole cluster. And we were reprocessing or reloading manually. And it was really hard because we had to go in and fire landers and do all sorts of things. It was quite tricky. And rollback of our ETL logic, well, we just didn't have that. So afterwards, what has happened? Pipeline delivery, as we mentioned, is now continuous. Our Redshift table creation and alteration, or the DDL, is automated. Our load cadence is hourly. And most importantly, our job processing is parallel. So we can run as many jobs, ETL jobs, as we want at the same time. Our reprocessing in reload is now one click via the Airflow GUI. So we can run any stage, any task quite easily. And our rollback of logic, that is instant. So here's our data processing platform. Airflow. Airflow is used only to orchestrate. There's absolutely no workloads that we're running on Airflow. It's an orchestration only implementation of it. And we use Celery. Our worker nodes auto scale off the Celery queue depth. So we can have as many workers running according to however many jobs that we might be wanting to run simultaneously. Our batch serverless data processing cluster hosts all of our workloads. It's running on EC2 instance types that are right-sized for our workloads, and we specify that via vCPU and memory settings. And the EC2 instance is auto-scale. History of job definitions pointing to previous ECR image builds are retained for instant rollback in case of a failed deployment. What that means is that there's always we automate a new job definition that points to a particular Docker image version or a tag inside the Docker repository in AWS. And that if, for example, our deployment fails and doesn't work, we just go into that job definition and we delete it. And all of a sudden, we've just rolled back to a previous incarnation of our ETL logic. And yes, our ECR repository, it's got a full history of all the builds so that we can roll back. But also, additionally, it gives us a little bit of extra capability. And it means that our ETL logic is available to be able to locked in for a particular version for an ETL task if we want in one of our DAGs in Airflow. So the replatform, what did we actually build? We built 4 things. We built an Apache Airflow DAG, and this DAG dynamically scans Salesforce to build up a list of objects for processing. We built a CRM to S3 CDC ingester. We're using PySpark with a processing framework, and that we use Delta.
I didn't get that. Could you try again?
Oh, Siri. And we lay that down in S3 in Delta Lake format, and that's an append. The third item that we built is an S3 to Redshift CDC PySpark cleanser. So that's we're taking the data that we appended into our landing area and that we then go and cleanse and dedupe and do all those wonderful things. And then at the end of that pipeline, we've got the PySpark Redshift no loader. And that builds our spectrum tables, and that it also optionally lets us build a materialized view on top of the spectrum tables too. So 4 things. So here's a pipeline. Here's Salesforce, and that we're doing an incremental change data capture requests. And this I probably might add is only for an individual object that I'm showing you, but we're doing this in the case of the demo, we'll be doing this for 300 plus objects. So we do an incremental load from Salesforce, and then we do an append, ingest it and lay it down in S3 in Delta format. And importantly, what Mahdi was talking about is that we're typing that data straight out of Salesforce. We're preserving the full data types that we can and converting them into Spark data types, and also having schema evolution turned on so that we can lay it down in S3. Then we've got a second job. That second job is the cleanser. And that is doing also an incremental read out of S3 of the Delta files that got laid down that are partitioned. And we run all our cleansing logic, and then the deduping logic, and then we lay down 3 different objects. And you'll see that in the talk. And then at the end of that second pipeline, we've got the no loader, and then that goes. And if there's a spectrum table there's nothing to do. If it's not there, it creates it. If there's schema evolution, it'll evolve the spectrum table, and that's in the article. And then also it'll do the same with a materialized view, which is really handy. So that gives us that powerful acceleration. So I'm going to do a demo now. I'm moving a little fast given the time constraints. But here's where to keep an eye on. So what you're going to see is one of our production loads. It's one I ran on Saturday night. And this basically copies everything out of Salesforce incrementally and lays it down, as you saw in that pipeline. And it's going to be running for about, I think, 314 or 316 objects. So where to look? The key things, it gets very busy and it's jumping around a bit because I'm refreshing browsers and things. But one of the main areas here is to look at the DAG details, because this will give you statistics. As I say, it's getting refreshed once every 15 seconds, and I'm accelerating this 6x. The other part of this is going to be the number of instances that are up at the moment in EC2 running by batch. And then these will be the actual batch queue that we've got, and also the instances and jobs. Now, understand these will be a little bit out of sync with each other. The data coming out of AWS to get into some of this is comes at a different speed to what we might see in Airflow, but Celery is the live screen here, and that you're going to see the number of jobs that are active here. But understand this means that the jobs are queued and they're waiting to be run, or they're running, or they're just about finished. So this may not mean that a job is actually running yet on batch. But at any rate, I'll get started and I'll talk you through one of our loads. So here we are. So as you can see, we're now starting up. We've got a concurrency of 90 jobs running, and they've been submitted, and we're just starting to get the instances coming up. So now we're about 30 seconds in, and we're starting to get success. Now, understand this 30 seconds is actually about 2.5 minutes with the warm up, but you can see now that we're starting to go through, and we've got 29 instances. So a maximum of two there. So that's like 58 jobs potentially running at the same time, all discrete, all separate from each other. Now, also, I'm just gonna slide through a little bit, and I'm gonna go up to about, in the interest of time, up to about here. And now we're gonna see an auto scaling event. Now, about every 10 minutes, batch checks itself if the workload's in the queue, and you can see now that we've scaled up to 37 machines. And we're going to see now that the Docker images that we've got are now caching on those EC2 boxes, and they're going to start to spin up, and they're going to start to process it, and the speed of the pipeline is going to increase. So these are all simultaneous Salesforce objects, all getting processed separately and then laid down in S3. Now you can see here we've got a job that failed, and it's up for retry. It's going to wait for about 5 minutes with Airflow, and then it's going to have another crack at it. And you can see now the numbers are climbing. You know, we're north of 700 jobs now. We're aiming for 1,256 to be complete, and we've got 74 jobs running in parallel. You can see this active 72, 73. It's sort of going up and down. So the jobs are going fairly fast here. Now the up for retry is going to happen in a second. And that should be, I'll slide forwards here because I think I can, because it's a video. And we can go to about here, I think, scale down. And we'll see the scale down happening in a moment. So keep your eye out here, that you're going to see this number drop down. Yep, and it's dropped by 10 machines. So it's now down to 27 from 37. So you can see the system is quite dynamic here, and it's processing these things. You can see the failure, the retry has succeeded, and it's gone through successfully now. So that's what I really like about Delta Lake, the resiliency that it gives us, and that the CDC, when combined with that, we can just retry a job and rerun it, and it just you know, it's no problem. So we can lose our spot bids. You know, machines can drop out from underneath us, and then the job can just retry itself, and it works. So you can see now we're starting to get to the end. Now we've processed over 1,200 jobs. We're probably about 25 minutes into the run now. And you can see we're just about there now. We've done everything except some other job that had about to retry. That's, we just got to wait for the obligatory 5 minutes that has to happen before the thing will be retried. Almost there, it's queued, it's running. And boom, we're finished. Now we just wait a few moments. You can see the queues, everything active is to 0. All the workers are at 0. We're just waiting for the cooldown, and there it is. All the machines gone. So that was one of our production runs. This is for Salesforce. This happens every hour for us since our release, and it's working beautifully at the moment. We're playing with concurrency. It's set to 90, but you know, we could make it narrower, we can make it wider, we can make it faster, but 90 seems to be good for us at the moment. It gets it done in half an hour. We're loading Redshift every hour, and it's pretty, you know, it's sort of cost effective. If the wider we go, then we start to get more startup costs. So what have we just done? We built 4 ETL objects to process 314 Salesforce objects into Redshift. 3 Redshift Spectrum tables with materialized views per Salesforce object. We ran 1,256 PySpark ETL jobs. Ran an incremental load of all Salesforce objects to Redshift in 30 minutes. And we ran a maximum of 74 PySpark ETL jobs in parallel. We rented half a machine day, but we spread it across 30 machines within half an hour. $9.57 AUD for the load. That's nice, but so what? What does this mean for our customers? If a Salesforce developer releases a new object, it will auto deploy to Redshift within 60 minutes. Nothing to do. If a Salesforce developer adds an extra column to an existing Salesforce object, it will auto deploy to Redshift within 60 minutes. Nothing to do. Salesforce data in Redshift, it will never be more than an hour out of date. Databricks, thank you so much for open sourcing Delta Lake and Spark, but Delta Lake, it must be a difficult thing, a challenging thing to run a commercial operation, but at the same time, release such solid, excellent capability out into the open source community. Thank you. Airbnb, open sourcing Apache Airflow, and one of my great open source BI heroes, Maxime Beauchemin, thank you. And the AWS Redshift team for facilitating and simplifying big data, particularly Delta Lake Spectrum integration, and also providing materialized view capability on Spectrum. Two fabulous things. It's just made Redshift awesome. It was pretty good before, but now it's awesome. And thank you, team. Shane Williams, our team lead, for making our team what it is. Doug Ivey, my partner in crime, for his help on the serverless data platform. Santo Vasile and Doug for their data lake migration from the mutable to immutable. Daniel Avestaviv for his knowledge and his help with CRM and Salesforce. And Ted Buchan at Platform Engineering for his deep infra expertise and his coaching for automation. Thank you. And Jane Crofts for her support. And finally, a gentle request to consider giving something back to open source. Please, if you use it, it'd be great, no matter how small thing you do. And thank you to you all for coming today from us here at Silicon Yarra. Questions?
Well, first of all, George, I think, massive round of applause, even if it's virtual, for like an awesome presentation and putting all of this together, because, this clearly wasn't just a Hello World demo. It's, a serious bit of capability that you've put together, both, from, I guess, ingesting from Delta Lake into Redshift, and also sort of doing the data pipeline from Salesforce to S3. And I think like the pipeline that you've built is just like, in my mind, world-class, because, there's just that replayability. Any sort of failures, it's just like, you just brush yourself off and carry on, and it's no sweat. So, gosh, well done. And that's definitely a conference talk if I've ever seen one.
Thank you. And look, the important thing is that when you come to cloud from a data center, you're really looking at that lift and shift through it, that lift and shift lens, and you don't even know, right? It's just where you are in your evolution. But when you get to cloud, and that all of a sudden, instead of, and you can say that I'm renting half a machine day, but you can rent it in 100 machines in 5 minutes. It just change. Once you can manage that flip and then start to use that paradigm more out in the cloud, it's fabulous. But we can be so bold and we can be so flippant with our data because we can trust stuff like Delta Lake and Redshift. It just works.
Yeah, no, fair enough. If I can ask you a question before we dive into the ones, we've had quite a few come through on YouTube. You know, sounds like you've solved a lot of sort of common data engineering problems, and I like how you've kind of, you know, your pipelines are just, you know, the thought that you've put behind them. But are there, what sort of problems are still on your roadmap still to solve? You can't have solved it all.
Oh, look, there's always stuff happening, you know. Spark keeps changing version, you know, so does Delta Lake. You get stuff happening. I mean, Spark's now at 3.01. So that's there's always going to be things that change and new functionality and new stuff that comes. But and we're at the moment, you know, we're finishing off the migration of our, as I said, our old data lake into the new, and then switching into this new platform, and we're really looking forward to turning EMR off and running everything, you know, in parallel. It's gonna change us. It's 8 hours of processing is going to drop down to about, I don't know, 1 or 2 at the moment. So it's big.
It's huge, yeah. Well, I'll dive straight into the questions on YouTube. I think you might have answered this one, but how do you control the resource allocation? No, sorry, it was, yeah, we'll start with this. How do you control the resource allocation for the individual PySpark jobs?
Well, batch is like batch is not so well known, but it's similar to Kubernetes, but there's a lot more simplicity to it. It's just built for batch workloads.
Yeah,
and it really makes it easy for us that we just put in the requests and it works it out for us. But you can get a little bit more particular with it if you want it to scale.
Yeah, so it sort of chooses like the number of vCPUs, the instance size and stuff like that, or?
Oh, well, we tell it how much RAM we want for a job and how much CPU we want for the job. And then it'll pick machines. And if, you know, particularly if we're out on spot, it will go and get a fleet going with various different machines. So, and then it'll just pop the jobs into the, you know, into one machine, or there might be more than one job in a machine, or there might be a job that spans machines.
Yeah, makes sense. How Delta Lake file format being accessed by Redshift? You said that was Spectrum. They've developed new functionality, right?
Yeah, so we've been testing both the old method that was originally in the Databricks documentation, and then the newer method, which is the way that they talk about using it with Athena or with Hive, and that was what Amazon released back in September, and we were just running both of them and then dropping materialized views over the top of both of them. So, and that gives us that native performance and lets us change the distribution methods and things like that.
So you don't need to convert Delta Lake file format to Apache or anything else?
No. We just put a map view over it, and then we can just treat it like any other table. We can use distribution keys, sort keys, you know, interleaved keys, anything we want. And, you know, it's quite handy when you want to spread out a star schema across multiple machines and you want it to be a performant.
Yeah, nice. Hashal asked, why did you not look at other ETL capabilities instead of relying on open sourcing? Is it just costs? I guess there's newer vendors and older vendors. I guess probably Talend or something like a new vendor could be Fivetran in this space.
Oh, look, I think look, I've been working with Spark for a little while, and been in with AWS. We came to the team, and the team was already using PySpark and EMR, so there was a natural progression for us to go forwards in a certain way. And I've always been particularly partial to Docker and containerization.
Yeah.
And batch was just a sort of a natural fit for us. And yes, it's you know, we didn't go with a vendor, and you know, that's just the way that it's sort of, you know, the cards have fallen.
Yeah, I guess AWS have just released recently AppFlow, which has got
Yes.
Salesforce.
Correct.
But yeah, it's just there's always considerations that go into all of these decisions. I'm
This
sure.
all started probably a little bit earlier than that when AppFlow came out, and we've got with respect to AppFlow, I think we're at this point where we've got different capabilities at the moment, but we certainly have used it and looked at it, and now that it's got CloudFormation automation capabilities that happened recently, I think that is also a very big positive for it to be considered, especially for the teams who maybe lack some of the more in-depth skills to build something like we did.
Yeah, it's certainly, you want a decent engineering team if you're doing what you've done. Racing through a few of the questions. Airflow supports EMR operators as well. You chose batch with EC2 over EMR. Just a real quick answer on that one.
Yeah, sure. So as I said, the steps API that is in EMR is basically the one that is being used, is the most simple to use in Airflow, though I do believe you can do Spark submits as well, which may be a little bit different. Yeah. But we found that you saw the warm up for us, the startup that you saw in the demo, we were getting 2-minute startup. I mean, look, if we were using this in full anger and going at full width for our serverless, running at 960 jobs wide, there's a good chance that we may even finish our load, before things have fully initialized with other things. So we can go much faster, but we for cost reasons we don't want to. And this works really well. The Docker caching in batch, just like it works with Kubernetes, but so much more simple. Yeah,
you don't need to spend that 6 months spinning up any Kubernetes cluster or whatever.
We're a data team, right? And we want to work for our customers. We're not an infra team.
I think it works well if you've got a nice infra team that has already set it up for you. Although, why reinvent the cloud, when you've already got services like Fargate Batch and things like that. But yeah, I mean, different. It depends, I guess, what company you're at.
And it depends on the skills, right? So the labor pool, the team skill, the people, the city that you're in, the stuff that you could get a person to build off the street in San Francisco, you've got no hope of doing it in Melbourne, given the statistics of just the deep labor pool there. We've got to work with the people and the skills and what suits these people. We can have great ambitions, but we just have to be realistic about what we can deliver at, with our teams, and respect the people that we work with.
Yeah, no, it's a very valid point that you raise. It's not all about the latest and fanciest tech that you can play with. It's all, team dynamic practicalities and stuff. David Howell's asked a couple of questions that I might try and collapse into one. He's asking how much data is coming in from Salesforce every hour. Sounds like it'd be a reasonable amount. I think we probably answered some of the batch EC2 questions. And then just a little bit on schema evolution.
Look, Salesforce, the questions on ingest, I must admit, I'm going to be a little bit coy to give volumetrics and things at this point.
Yeah.
Been asked to hold back, but we're trying to share as much as possible. And but as far as, what was the other question?
Schema evolution and glue catalog sync up. I think you're using a different method.
Yeah, look, schema evolution, that's really, again, we're protected so much by Delta Lake that it gives us that capability. I recommend people go and read the article in Medium, and it really goes in and drills into how to get a data frame in Spark and how to get it to evolve in Spectrum, And then that just continues on, and you know, it's very simple to create a materialized view.
Yeah.
We just, you know, we're in Python, and we use scopg to talk to Redshift. Like we just use, you know, we talk to it that way through JDBC. So it's
just Postgres connector or whatever. Yeah. Wow. Nice. And Tanvir, obviously working in, if you're a data engineer with your weight or whatever, in gold or whatever, you need to be talking about data reconciliation and data quality testing. Any comments or sort of best practices on that one?
Look, I think that's we're happy to talk to people and you know, in lots of talks.
Yeah.
Obviously we're doing cleansing, and it's, you know, and again, Delta's wrapping stuff up. It does lots of tests. You know, it just naturally tests for dupes and all that type of thing.
Yep.
So we've got some lightweight stuff happening naturally as part of this library, which is why we use it.
Yeah.
But you know, maybe the deeper stuff, maybe we can leave for another day.
Yeah, I can imagine, like reconciliation and data testing, and I'm going to do a call out right now. If you've got a good story to tell on that space, I think there's probably 1,000 data engineers on our Slack group that are interested to hear what you've got to say, because yeah, it's a conversation that comes up time and time again. So, you know, George and the folks from Seek or anyone else, if you want to put your hand up to present on that topic, I think there'd be a lot of eager ears for that one. What is it? Cherry Yakadu says, love Silicon Yarra. Thanks for the photo, George. Did you take that one yourself?
That is my bicycle on a bridge. I love riding down the bike path, and I love working in Melbourne. And yeah, it's a great part of the world. I miss it very much because I'm cooped up at home, but I'll be back there as soon as possible.
Well, wishing all you folks in Victoria all the very best, because I know you've done it pretty tough over the last couple of months, and it's great to see coming out of the lockdown and, you know, coming into summer. So that's a welcome relief, I'm very sure. Yeah,
it is. But thank you everyone for coming today and listening. It's been a pleasure to be able to share.
Cool. Well, we might leave it there then. That's a wrap. Thanks so much, George, Mahdi, and Mary, for all of your insights. I think, you know, everyone's gotten a great deal out of it. So they're all on our Slack group, so feel free to send them through some questions, and, you know, perhaps we can get them to do some follow-up presentations. We'll let you know when we've got our next meetup on. And thanks once again. Ciao for now.
Thank you.
Thank you so much. Bye-bye.
Take care. Bye-bye.